last time we went through the overview of the NIM language just from the front website. And we found that there's this NIM Basics tutorial. And it says that it's for people with minimum previous programming experience. I skimmed through it later, and I think it'll be actually good enough for maybe not people with totally minimal previous programming experience, but with just some basic programming experience. Then we'll be able to follow it, because this tutorial doesn't try to explain how programming works. It just explains some concepts. So previously, we went through the installation. We installed NIM, we installed the extension, and we tested the installation by writing our Hello World program, which is a nice one-liner. So that's always nice to see. And from here, we'll be able to continue. Oh, it's worth noting that we were compiling our program with NIM C for compile and the name of our NIM file. And we could also compile and run at the same time by adding the R flag. In our VS Code setup, we'll be able to just do Control-Alt-N. Let's see if I'll hit Control-Alt-N. Bam, the whole thing just ran, and we're good. So, going back to our tutorial. Today we can start with the naming values. Maybe I'm gonna add a little background music, as I don't know. Wait a moment. We have a problem with live stream on YouTube? Huh. Stream status poor. We have more than one ingestion. I see. Stream is still going. Looks like our live stream is going. Okay. Cool. So let me just quickly grab some music. And we'll place it in the background. Hopefully that's not too loud. Alrighty, let's get back to it. Okay. Oh, we are not live? We are. Sorry for the confusion. I'm new to this. And this is the first time where I'm actually streaming to two places at the same time. Twitch and YouTube, so it's a little bit confusing. Alright, let's get back to it. So, in the NIM language, naming values. It's often helpful to give the values in our programs names to help us keep track of things. If we ask a user for his/her name, we want to store it for the later usage, without asking for it again and again every time we need to do some computation with it. An example, pi equals 3.14. The name pi is connected to the value 3.14. From our experience, we can tell that the type of a variable pi is a decimal number. Yeah, we presume this will be a float number, as we know some programming. Another example would be first name equals Alice, where first name is the variable of is the name of a variable with the value Alice. We would say that the type of this variable is a word. In programming languages, this works similarly. These name assignments have their name, the value, and the type. Yes, this is a statically typed language, so we'll need to specify types. So variable declaration. Nym is statically typed programming language, meaning that the type of an assignment needs to be declared before using the value. In Nym, we also distinguish values that can change or mutate from those that can't. But more on this later. We can declare a variable, a mutable assignment, using the var keyword, just by stating its name and type. The value can be added later by using this syntax. So yeah, we specify var, give it some kind of name, colon, and we specify the type. So this is something that we'd see in TypeScript, and Go is just, different languages specify, we can have let, you can have var, depending on language. If we already know its value, we can declare a variable and give it a value immediately. Var, name, type, and value. Yeah, of course, those Angular brackets are used to show something you can change, so name is not literally the word name. Yeah, that's obvious. So, Nym also has type inference ability. The compiler can automatically detect the type of a name assignment from its value without explicitly stating the type. We'll look more into the various types in the next chapter. So we can assign a value without an explicit type like this. Okay, that makes sense. var something equals something, and the compiler will be smart enough to figure out what type the value is. An example of this in Nym looks like this. Var a int. So we declare a variable a of type int as an integer with no value explicitly set. So we know that we have integers available just as int. And variable b has a value of 7. This type is automatically detected as an integer. Perfect. Less work for us as programmers, the better. When assigning names, it is important to choose names that mean something for a program. Simply naming them A, B, C, and so forth will quickly become confusing. It's not possible to use spaces in a name, as that would split it in two. So, if the name you choose consists of more than one word, the usual way is to write it in camel case. Yep. First, lowercase, later words start with capital. Note, however, that Nym is both case and underscore insensitive. Oh, meaning that hello world and hello world would be the same name. The exception to this is the first character, which is case sensitive. Names can also include both numbers and other UTF-8 characters. Even emojis, should you wish that. But keep in mind, you and possibly others will have to type them. That is interesting. So let's try it. I don't know if I worked with a language that's case insensitive before. So we can do, make it a little bit larger. Let's say that we declare a variable, it will be something. And we say, let's turn off compiler for now. Save completions, okay. So something is hello, right? That should be a string. Echo something. Would that work? Wait, I need to save it first. Ah, that works. That's so weird. So if I'll make it capital, now look how it changed the way it's displayed. So that will definitely not work. Undeclared identifier something. Okay. But if we'll just keep as, and I don't know, add some random craziness. Ah, about indentation. Wait, does it? Trailing underscore. Okay, so it doesn't like trailing underscores, but if I'll put a, nope. What the hell? Okay, so it doesn't like underscores. Something, right? This is fine, but if I'll do underscore, now it doesn't mind. still doesn't mind. It doesn't mind all those things. But if I'll put two next to each other, oh, that's where it goes. So no two underscores next to each other, but this, if I save it, should still run. That is so weird. I guess it could make some typos work, but I can imagine situations where that would be actual use case. Interesting, and they said that we can also declare variables with emojis. So let's type some emojis. I don't know. Laughing face equals, and we just also do another laughing face. And we don't have underscores. Save it and run it. And not supported define. Wait, what? Oh yeah, it runs. Hello. It's a little bit crazy. But the question is, can I just do without a character up front? Oh no, it's possible. You can do weird stuff with that. Hello there, and a wave. Will that work as well? Let's save it, and let's run it. There we go. It works. Huh. Wow, alright. Why not? Possibilities are endless. I like it. Alright. So include both numbers and other UTF-8 characters. So I guess if you write in language that has weird characters, like, you know, non-ASCII, you can just do that. Huh. That brings me some flashbacks. A few years ago, I worked in a company that... I worked for a Swiss company. But as the company was Swiss, the office was... bad idea at the same time. It's like, you know, giving people more things to have fun with means that more things can go wrong. Alright, so instead of typing var for each variable, multiple variables, not necessarily of the same type, can be declared in the same var block. And nim blocks are part of code with the same indentation, same number of spaces before the first character. And the default indentation level is 2 spaces. You will see such blocks everywhere in nim program, not only for assigning names. Okay, so we basically have a block var and 2 spaces, and we can assume that it's for all. Okay, it looks tidy, I like it. You just have a big header telling you that, okay, now we'll be declaring things. Cool. And this was the character, character string, and this will be an integer. In nim, tabs are not allowed as indentation. You can set up your code editor to convert pressing tab to any number of spaces. In VS Code, the default setting is to convert tab to 4 spaces. This is easily overridden in settings. Okay, sure, we can check If our VS Code, look at that, it wants 4 spaces. And then using spaces, 2. There we go. Okay, let's continue. As previously mentioned, variables are mutable. An example, their value can change multiple times, but their type must stay the same as declared. Okay, so they're basically mutable. We declare a variable where variable, or means it's something that will change, and then we have can assign however many times you want. But if we will try to assign a string of characters to an integer, it will just like, nope. If I'll try to copy it, we'll probably, let's see what the compiler errors look like. If we'll paste that, we already get the type mismatch. Got string for hello, but expected int. That's nice and clear. If we'll save it and try to run it, what will we get? The same thing. Which file, which location in the file, and just a clear error. I like it. No mysterious 30-line errors. Alrighty. Immutable assignment. Unlike variables declared with var keyword, 2 more types of assignment exist in NIM, whose value cannot change. One declared with the const keyword and the other declared with the let keyword. Okay. The value of an immutable, so we start with const. So that will be pretty straightforward. Let me just make the music a bit quieter. It's really loud for me. I don't know if we have any viewers. If the music is too loud or not, please let me know. Maybe I'll figure out how to read chat. Okay. So, const. The value of an immutable assignment declared with const keyword must be known at compile time before the program is run. Okay. That's pretty classic for programming languages. Pretty typical. For example, we can declare the acceleration of gravity as constant g equals 9.81, or pi as constant pi 3.14, as we know their values in advance, and these values will not change during the execution of our program. Okay, that will work, but when we'll try to assign it, it will be an error. If instead we'll declare a variable h and create variable I where we try to use h, we should get another error. Let's see what those errors look like. I am curious for those errors. So we'll see here, 35 cannot be assigned to what? Is that like 3 separate lines? Assigned to. Oh, okay. I guess it makes sense in English, just period. 35 cannot be assigned to. I don't like that error. I guess you're getting good used to it. This is the same when we actually run it. 35 cannot be assigned to. Okay, so I guess it takes the value instead of saying that it's g cannot be assigned to, or like constant g cannot be assigned to. That could be improved, I guess. Maybe there's some reason behind it. And the other one was where we tried to use a variable that should be only runtime in a constant. So variable h is not evaluated at compile time. It is variable, and its value can be can change during the execution of a program. Consequently, the value of constant I can't be known at compile time. Okay. So let's see the error. What we'll get here. I guess save file. Yeah, that clears it. Cannot evaluate a compile time h. Okay, that points us exactly to h. Hey, this is not compile time. Cool, that's clear. Alrighty. In some programming languages, it is a common practice to have the names of constants written in all caps. Ugh. Constants in nym are written just like any other variable. Thank you. Let. Yeah, because my opinion is that if we have constants as, the special things of all caps, it feels like it would mean that, hey, this is this rare thing, we should use it rarely or declare it somewhere far away. But I presume you can declare it anywhere, somewhere in the middle of the code. So why make it where it's a special thing that would suddenly make some people think like, I better avoid doing that because it just puts those all caps everywhere. It looks ugly, and I know it's something special. I should use it rarely. I don't know. That's the feeling I had initially when I started programming, where like, I need to leave constants for those special cases. Well, hey, whenever you know, just use it. All right, let's go to let. Immutable assignments declared with let don't need to be known at compile time. Their value can be set at any time during the execution of a program, but once it's set, their value cannot change. Oh, that's very nice. So when we say let j is 35, we try to reassign it, we get an error. And we create a variable k, and we create an immutable variable L, and we can use k. This should work, yeah, because this is during runtime, so by the time this is being executed, the k is known. Okay, that makes sense. So let's just see that this is same, like, not very helping error as in the other case. Yeah, j cannot be assigned to. Okay, this is a little bit more helpful. We don't have that. 35 cannot be assigned to. We have j cannot be assigned to. Okay, that hints at something, because if we'll make it constant, right? We have 35. So it pretends, I guess the compiler or whatever it's running before the errors are being found. I guess compiler literally sees, okay, this is a constant, let's just grab it and just paste it here, and we end up with this code. And if I'll do save, we have, yeah, 35 cannot be assigned to, exactly the same thing. Okay, problem solved. All right, now we know. Okay, in practice you'll use let more frequently than const. Yeah, of course, because in this case, const works like if you were writing your JavaScript or TypeScript, we're encouraged to use const every time you know that that value won't change, because that, speeds things up a little bit, makes sure that you won't mess things up. So, yep, so let is equivalent of what you would have in JavaScript. Constant is like totally, because it's pre-compilation or like during compilation, this can be set in runtime. Well, you could use var for everything. Your default choice should be let. Use var only for the variables which will be modified. Yes, and in that case, the var is becoming special, because this indicates the moment you see var, it's like, oh, this thing will be modified at some point. I should pay attention to that. It's not just a little value that I'll just save and use. This will be something that will be changing. So I really like it. Okay. Time for another one, which in this case is basic data types. Integers. As seen in the previous chapter, integers are numbers which are written without a fractional component and without a decimal point. For example, 32, -174, 0, 10 million, so we can use underscores. Cool. Are all integers. Notice that we can use the underscore as a thousandths separator to make larger numbers more readable. It is easier to see that we're talking about 10 million when it's written as this, rather than this, where you actually need to start squinting in 1 to 3, 1 to 3, and then, oh, we have extra 0, so it's not million, it's 10 million. So they said that we can use it for thousandths, but I wonder if we can just place them wherever. Let's check that. So let whatever I equal, and we have this, right? This is fine. It's happy, just unhappy that we didn't use it. There we go. Echo I. Perfect. It's been used. What if I'm gonna remove 1, 0? It's fine. It doesn't complain. I can run it, right? Here. Yep, it runs. So I guess I could just do that if I wanted for some reason. It's gonna let me run. Perfect. Okay. So we can use it as a 1000 separator or just any kind of separator. Cool. The usual mathematical operators, addition, plus, subtraction, hyphen, multiplication, asterisk, and division, /, work as one would expect. The first 3 operations, 1, 2, 3, always produce integers, while dividing 2 integers always gives a floating point number. Okay, that makes sense. A number with a decimal point. As a result, even if 2 numbers can be divided without a remainder. Alright, so if we're gonna basically divide 2 by 2, we're gonna get 1.0. Okay. Integer division, division where the fractional part is discarded, can be achieved with the div operator. Okay, that makes sense. An operator mod is used if one is interested in the remainder, as in modulus, of an integer division. The result of these 2 operations is always an integer. So you have A and B, and we can basically add them, subtract, multiply, divide, but it will be, the result will be a float, a fraction. We can divide, which will be int, we just discard the floating part, and modulus, standard. Okay, cool. And exactly. So for normal slash, we'll get this result, while for the div operator, we'll just get this without the everything that's after the what do you call it, floating point? Okay. Decimal, I don't know. I haven't studied math and English, so I'm not sure. Alrighty. Floating point numbers, or floats for short, are an approximate representation of real numbers. It's good that they're pointing that out here, as this is for new programmers. Yes, floats are approximate representation. They can have little glitches, hopefully not as much as in JavaScript, but they're approximate. That's, for example, why when playing Minecraft, you have, if you go far enough, far away, very far away, you get to what they call far lands, where things are getting wonky, and it's because that far away, the numbers become so large that we're starting to lose precision, and that's where glitches happen. That's why for many years in various games, you couldn't have very large maps, because suddenly animations and things were just glitching out, started shaking a little bit, and as further away you went from the center of the map, the more glitches happened. Yeah. Alrighty. So, for example, 2.73, negative 314, 5.0, or 4, and exponential 7 are floats. Notice that we can use scientific notation for large floats, where the number after e is the exponent. In this example, 4e7 is a notation representing 4 times 10 to the power of 7. So basically 4 and 7 zeros after it. Alright. We can also use the 4 basic mathematical operations between 2 floats. Operators div and mod are not defined for floats. It makes sense. Cool. So we get all that. That's pretty straightforward. I don't think we need to, look at examples of that. Okay. Next, the precedence of mathematical operations is as one would expect. Multiplication and division have higher priority than addition and subtraction. Sure. So if we want to print that, first we'll do 3 times 4, which will give us 12, plus that 2, will be 14. There we go. And here, division first, so we get 2, 24 negative 2, minus 2 will be 22. And of course 0.0 because we divide it here, so we got a 2.0, and I guess because this is 2.0 and we subtract it from integer, everything just turns into floats just to handle the possible case. Okay. Let me try that. That would be interesting if it would just automatically round things up like that. Let's go here and let's see that. Oh, I didn't copy. Come on. Copy. Paste. And we can run it? We can. Okay. Huh. I'm surprised that it actually automatically changes, you know, as we have a float here. Okay. Wonder what the rules are for that. Converting floats and integers. Mathematical operations between variables of different numerical types are not possible in them, and they will produce an error. So we get 5 plus this, we get an error. And why didn't we get an error here? Because it wasn't explicitly as that? Yeah, so if I will do 8.0 by 4, it still works. Huh. Very interesting. So if we'll go 23, right, plus 3, that's fine. 3.0, that's not fine. But if we'll do divide by 2, what the hell? Why is it suddenly a mismatch? This is float, this is float, this is float. Huh. Very interesting. I guess the only explanation of it working like that here is a compiler did something to it. It's interesting. The values of variables need to be converted to the same type. Conversion is straightforward. To convert to an integer, we use the int function, and to convert to a float, the float function is used. Okay, so you can just wrap the whole thing in float and int, similar to JavaScript. Okay, that makes sense. I want to try something that I saw somewhere. So let's grab this code. Okay, and this should be happy. This is our integer, this is our float, and we can convert an integer to float, and that will, I guess, print it out with a float. Yeah, it printed out a float, while if we get a float and we turn it to integer, it will just discard everything. That's not a whole number. And we can add those together now because this turns e into float, and we have that. And or we can do everything with floats. I want to try something because in few places I saw that you can actually do e dot float and f dot int. Haha. There we go. So e dot float plus f dot int. Save and run. Oh, I like how to have that option. I don't know, for me, whenever you don't have like million parentheses, it's just more readable. I guess, I don't know, for me. I like this approach. Where you can convert just by doing dot something, dot something. All right. When using the int function to convert a float to integer, no rounding will be performed. Exactly. The number simply drops any decimals. To perform rounding, we must call another function, but for that, we must know a bit more about how to use nym. Okay. So I presume, knowing some other programming languages, if I wanted to round it, because right now, when we turned f into integer, it dropped the whole thing. So basically floored it. If it were rounded, it would go to 24. So if we'll go echo round and f. Okay, unidentified round. Does it have like okay. Round. Nope. We don't have it available. I'm sure we just need to import some math or something. We'll learn about it later. All right, let's move on from numbers to characters. The char type is used for char as char. I never know how to read it. Char? Because you say character, but you don't want to say car. It has H in there. Char. Not character. The char type is used for representing a single ASCII character. Okay, that's, I guess, important. So this is not Unicode. This is simply ASCII. So we are limited. Okay. Characters are written between two single ticks. Instead of double quotes. Characters can be letters, symbols, or single digits. Multiple digits or multiple letters produce an error. Okay. So we have let and bam. Strings. Yeah, we just declare different things. But yeah, this won't work because it should be a single character. Not this is two characters. This is two characters as well. Yeah. Okay. Simple. Strings. Strings can be described as a series of characters. Their content is written between two double quotes. We might think of strings as words, but they can contain more than one word, some symbols or digits. So we can basically do whichever we want. This will be an empty string. Yep, empty string. This will be just 2 digits, 3 and 2. It's not a number. It's double quotes making it a string. And exclamation mark is just, even though it's only one character, it's not a char because it is enclosed inside of double quotes. Okay. Special characters. If we try to print the following string, yep, even syntax highlighting shows that this will be a new line and this will be a tab. The result will be, bam, some, and we don't have n because that's /n. And tips. Okay, this is because there are several characters which have a special meaning. They are used by prepending the escape character // to them. /n is a new line character, /t is a tab character, and 2 backslashes. Yep. Since the first backslash is used as the escape character, so this basically signifies that, hey, we are going to type in some special character. And then it counts to this, oh, the special character is this. And there we go. If we wanted to print above example, as it was written, we have 2 possibilities. Use / instead of slash to print backslashes. Like here, we basically need to make double backslashes every time we actually want to type a backslash. Or use raw strings, which have syntax of those double quotes just with R in front of it. And it needs to be immediately before the first quote, no spaces, no shenanigans. In which there are no escape characters and no special meanings. Everything is printed as is. All right. That's simple. I like that there's no crazy, like different languages have maybe backticks or some ats and everything. R for raw, and that's it. I like it. There are more special characters than ones listed above, and they are all found in the manual. Okay, I presume they're all classic, no frills, no thrills. Okay, string concatenation. I'm going to be curious about that because I find many languages just doing weird stuff. Like, why are you doing that? Why are you making it more difficult? I mean, there are reasons for it, but I hope this is not one of those languages. And strings in NIM are mutable. Okay, that's interesting. Okay, I like it. Meaning their content can change. So for me, what it means is like, okay, every time I'm adding something to a string, you know, like add this and that and that and that, that means that I'm not doing something that will happen, for example, like in C#, where you're copying the whole thing and adding to it, like, you know, okay, we had a string of length of 30 characters. We want to add 3 characters. We need to now declare a new spot in memory that is 23 characters long and copy the first string there and fill the rest with whatever we wanted to add. You know, like suddenly you need to do a lot of copy. Here you don't have to. Just with the add function, we can append either another string or a character to an existing string. Awesome. If we don't want to change the original string, we can also concatenate, as in join together strings with the ampersand operator. This returns a new string. Okay, so we have both options. We don't need to, we can add to the string or concatenate them together. So we have P as ABC, Q as XY, and R as Z. If we do P.add DEF, that means that the P will now be ABCDEF. So from now, the P will be this. So the P is now ABCDEF. Perfect. And they say if we plan to modify strings, they should be declared as var. That's good to know too. Okay. Adding another string modifies the existing P in place, changing its value. Then we have Q.add_R. So we took the Q, which is XY, and we added a character. See, that's a character, not a string. And now Q is now and should be XYZ. We can also add character to a string. Yep, XYZ. Okay, an echo concat P and Q. Okay, this is nice and readable. I like it. I guess initially I will be confusing it with like a bitwise and from many other languages, but yeah, I like it. It's simple, quick. So if I'll do that with P and Q, so that would just concatenate them, won't change them, so it should be A, B, C, D, E, F, X, Y, Z. So let's see, concat. Yep, we've got the whole thing. And if we print P or Q after that, we still see that they haven't changed. Okay, concatenating two strings produces a new string without modifying the original strings. Awesome. Okay, I really like that implementation. So we saw that we can create a string simply by saying var hello equals hello world, right? Echo hello. So this is real simple. We do that and we have hello world. But earlier we tried to put emoji here. So if we put emoji, right? Save it and we run it, it works with the emoji. So I guess because these are just characters, the emoji is several characters long. Because Unicode was designed basically to work where each of those emojis and special characters can be made, you know, with special. First, you have special characters that denote that, hey, we're putting in Unicode character here and then other specify as value, and therefore we can, you know, have emojis that's just several characters. All right, that's simple enough. No craziness here, but I guess keeps it close enough to how things work in C and C++. By being just ASCII, and therefore, you know, we can easily compile it to something that runs fast. Okay. That makes me satisfied. Let me just get some water. I'm not used to talk so much. Okay. So, continuing. We now can go through Boolean values. A Boolean, or just bool, data type can only have two values, true or false. So unlike Python, even though it all looks like Python, true and false are with lowercase first letters. Okay. Booleans are usually used for control flow, and they are often a result of relational operators. Okay. The usual naming convention for Boolean variables is to write them as a simple yes/no, as in true/false questions. Is empty, is finished, is moving. Awesome. I am so happy that in this introduction tutorial they are adding this is empty, is something. I find it really frustrating where somebody declares a variable finished. Just by having this is in front, you are explicitly saying that it will be yes, no. And it helps with readability so much. The moment you say is, okay, that's gonna be a Boolean. Don't put random b in front of it for Boolean. Just do is finished, is empty. Or if you have a single Boolean value that is referring to something, you know, we can do var is finished and say it false, right? Oh, sorry. Or var are finished. And it still signifies that, okay, this will be just yes or no, because are finished or are not finished. That's the only choice. But maybe, you know, in the context makes sense. So sometimes you might write an application that deploys several workers or something, and you're writing some code that waits for them, and you have a while loop or something, and you need to have a variable that you check if everything finished. So you could do is finished, but maybe you want to be a little bit more aware. In your context, you think it's better to just use plural. Just use are finished, and it'll be still very readable, and it's just 3 characters. Just make it so much easier to read. So, very happy to see that here. Relational operators. Relational operators test the relation between two entities, which must be comparable. To compare two values are the same, equals, as in two equal signs, is used. Do not confuse it with single equals, which is used for assignment. Okay, so this is classic. I presume there's no triple equals from JavaScript here. Although, as I was peeking through some other examples, in NIM you can actually declare your own operators. Like, you don't need to just replace the existing ones, you can just make your own. And you can make quadruple equals if you want to do something crazy. Nothing is stopping you. You can make 5 equals as an operator for some crazy comparison, and it will let you. So that's awesome. And cruel as well too. So here are all the relational operators defined for integers. Okay, so we have 2 integers, g and h. N is greater than here. G is smaller than h. G is equal to h. G is not equal to h. G is greater than or equal. And is smaller or equal. Okay, all the classic ones are here. And just for each one of them, returns either true or false. Awesome. We can also compare characters and strings. So we have 3 characters, A, D, and Z. And I is smaller than J. I is A, J is D, so I presume this is based on the numerical representation of ASCII character, which is from 0 to 255. So A is in front of D, so yes, that would be true. While, let's see, I less than K. I is smaller than K. I'd say also true. In this case, A is before Z, and also Z is after, or wait, in ASCII, what comes first? Uppercase letters become before lowercase letters. Yeah. Oh, so uppercase are before. Okay, so in this case, it will be false because K, even though it's Z, it's capital Z, is before A. Okay, cool. Simple enough. Just a simple explanation. You can imagine that as in ASCII, you have, like for each value, whatever, 6 and whatnot. This is, I know, a space. It's not really that. This will be A. This would be B. And number 3 is C, something like that. I remember that number 13, for example, is the new line character. So basically, those characters are defined as, something, something, something. And then you have A, B, C, D, E, and ending with Z. X, Y, Z. And then suddenly it switches to A, B, C, D, E, and goes on, and X, Y, Z. And then, for example, goes through numbers, and then some different symbols, whatever, until it fills up all the 255 characters. And that's how their terminal works, by just displaying those ASCII characters. There are all the lines for symbols in Sinclair there. But what matters here is that capitals are before lowercase. That's a quick explanation. I presume it's very chaotic, but it's there. Okay, so let's move on to comparing strings. We have 4 of them declared here. Echo M is less than N. So is AXYB less than AXYZ? I say yes, because A's are exact the same, X's are the same, Y's are the same, and then we have B, lowercase b and lowercase z. Then lowercase will be before it, therefore M will be smaller. Is number 2. String comparison works character by character, exactly. First 3 characters are the same, and the character B is smaller than character Z, exactly. So let's go to another one. N is less than O. N less than O. So in the first character, instantly we have that the A is less than B, so N will be smaller. So number 3, string length doesn't matter for comparison if their characters are not identical. Okay, big if their characters are not identical. So I guess we're going to the last one. O is less than P. So we have O as BA and P, which is BA with space. So now we get to the situation where they have the same letters, at least the beginnings, but they're not the same length. So these are equal, and suddenly we have no more here and something here. So I presume that nothing will be less than something. So I would presume that this will be true. Shorter string is smaller than a longer one. Exactly. At least when they both start exactly the same. Cool. Logical operators. Logical operators are used to test the truthiness of an expression consisting of one or more Boolean values. Logical and returns true. only if both members are true. Yep. Or returns true if there's at least one member which is true. Okay. Logical XOR returns true if one member is true but the other is not. So it's basically if both of them are true or both of them are false, this will return false. It will return true only if just one of them is true and the other one is not. Logical NOT negates the truthiness of this member, changing true to false and vice versa. It's the only logical operator that takes just one operand, as in you can just say not and something. It's not sandwiched between two things. So let's see. T and T as true and true, that will give us true. Because true and true is true. True and false will give us false because both of them are not true. And if we do false and false, will give us false because and is happy only when both things are true. So this is like, the basics of programming and basically logic. Then we have OR. True or true. Well, either one of them is true, so yeah, that's true. True or false. At least one of them is true. Therefore, it will return true. False or false. Both of them are false, therefore there's no truth anywhere, so it'll be false. Then we have XOR. So that's the funny one, and used rarely, because I think the big problem with it is that it's rarely accessible as that simple operand. I like it because you can just type XOR, and you're done. So, true, XOR true. This will return false because this wants one of them to be true while the other one to be false. Here both are true, so it will return false. Here we have one true and one false. Therefore, it will be happy. There's this, two are different. So basically we get true here. False, XOR false. This will return false because, they're both the same. So XOR returns true only if both sides are different. And then we have not. Of course, not true will be false, and not false will be true. Okay. We have confirmation of that. Yep, all makes sense. Relational and logical operators can be combined together to form more complex expressions. For example, and here we have the parentheses. So first we evaluate 5 is less than 7, so that will be true. This whole thing will be replaced with true. And I have this whole thing where we, I guess, evaluate that, which will be 20 is equal to 32 minus 12, it began 20, so 12 equals 20. That's true. So we have true, and therefore the whole thing will become true. Yeah, and I'm explaining basically the same process here. So at the end, we get the final result of true. Awesome. Recap. This was the longest chapter in this tutorial, and we covered a lot of ground. Take your time, or go through each data type and experiment with what you can do with each of them. Types might seem like a restriction at first, but they allow the NIM compiler to both make your code faster and to make sure you're not doing something wrong by accident. This is especially beneficial in large code bases. I very much agree with that. Now you know the basic data types and several operations on them, which should be enough to do some simple calculations in NIM. Test your knowledge by doing the following exercises. Okay, so we'll be doing exercises. That's fun. All right, so let's see. Exercise number 1. Create an immutable variable containing your age. In years. Print your age in days. Okay, 1 year is 365 days. So, okay, So let's do that. We assume that it's 365. So we say that they want variable with var, immutable variable. Okay. So we do let age, and we say it's 32. And that'll be an integer. And then we want to echo it. Let's do print it out. So it's our age times 365 days, right? 365, yes. So we print that. And I lived 11,680 days. It doesn't feel like I lived that many days. I should have more practice in getting up in the morning, guys. Oh, that's tough. All right, that was exercise number 1. Check if your age is divisible by 3. And as a hint, use mod as modules. All right, that'll be simple. So we can do, hey, let is divisible by 3. And we'll decide that is my age as in days? No, just age in years, I presume. So in years. So let's do age, right? And we do mod 3. So modules 3. So what it will do, it will basically print out. This will take the age divided by 3 and returns the remainder of that division. So if we had 0 mod 3, that will be equal to 0 because there's no remainder. Then we can do 1 mod 3. We'll return 1 because we can't really divide it by 3 yet. We have remainder 1, 2 will be 2, and when we get 3 mod 3, we can divide it. We got 1 3 inside 3 and nothing left. So again, we got 0. 4 will be 1, and it goes on, will be 2 0 1 2 0 1 2 0 1 2 0. So basically, if you want to check if something is divisible by some number, you take that number, mod whatever is divisible by, and you check if it returns a remainder of 0. So age mod 3 equals 0, and I presume that equals, I mean, this is like calculation operation, so that should be it. Yeah, it doesn't make sense to be something else. And already nymph compiler figured out, okay, this means that this will be a bool. So let's do echo, and we do age of, and we print age. Well, that's those comma, I recall, comma, age, comma, is age of divisible by 3, question mark, and we get the answer of is divisible by 3. And when we run it, get an answer. It's not divisible. The next year will be. Alrighty. Okay, we have first time chat. Hello, sorry for bothering you. I want to offer promotion. Oh, no, thank you. We got first spam. Let's see if I can learn how to moderate it. Okay, I don't know how to moderate here yet, so doesn't matter. Whatever. Okay, let's continue. Create an immutable variable containing your height in centimeters. Okay, print your height in inches. 1 inch is 2.45 centimeters. Okay, that's a simple task. So we can add, again, immutable, so we let height in inches. Wait, I need to do it in centimeters. Yeah. Height centimeters. And we'll set it will be I don't know. Let's do 180. I'm not that tall, but sure. So they don't say if it should be a float or not. If we need to print it out in inches, we can print it out as full inches or as something with a decimal. So let's go with full inches for now. So we have an integer of 180, and let's do let height inches, and that will be the, if 1 inch is 2.54 centimeters, so we basically need to get height centimeters divided by 2.54. That's unhappy because this is float while this isn't, so let's just go simple ways. There we go. All divided. Both would be, this is float 64 while this one is float. Okay, that's interesting. I guess we have like a generic assumed one and then not assumed. Oh, look at that. This is 64. This is 32. Or I can do float and it will be just float. That's interesting. Okay, so let's echo my height in inches is, and we can print it out here. It will be height inches. Let's save it. Let's run it. And therefore I'm 70.86. But if I wanted to do it just in as an integer, let's say round it down, it will be integer of that. And let's round it again. And we have that my height in inches, it's 70 inches tall. It's probably closer to something like that. So let's save it and run it again to lie a little bit less. 68 inches. Sure, why not? Okay, what is next? A pipe has 3/8 inch diameter. Express the diameter in centimeters. Okay, 3/8 of an inch to centimeters. So let's do that. So pipe is let pipe diameter is 3 divided by 8. Okay, that will be a float. And let pipe diameter centimeters. So we take that pipe diameter and this time we convert from inches to centimeters times 2.54. Okay. So we could go fancy and go here and say, hey, we have a constant. Centimeter to inches. Sorry, inch to centimeters. And that will be 2.54. So if we don't want to type that same value everywhere, or I don't know, at some point something in the world will be recalculated, we can just paste it here. And we can paste it here. And there we go. So, echo pipe diameter in centimeters is, and we do pipe diameter cm. Save, run. There we go. It's 0.95, 0.9525 centimeter. So, 9.5 millimeter. Okay. What is next? Create an immutable variable containing your first name and another, okay, containing your first name and another one containing your last name. Make a variable full name by concatenating the previous two values. Don't forget to put a white space in between. Print your full name. Okay, let's go. They want it to be immutable variables again. Let first name, this will be Ben. Let last name, I'll be Dudek. And we need to do, they want also, yeah, it makes sense. Let full name, and that will be first name, and we concatenate ampersand. We make sure to add a space, ampersand, and last name. Okay, so we add all those together and we do echo my name is, and we put full name. Save and run. There we go. It's here. So I wonder if we can mix strings with characters here. If I'll just concatenate a character, run it, works. Thank you. I believe I found some other programs where it's like, oh, you can't concatenate a string with a character, so you need to make a string out of it. I wonder if that works. What? A character for expected string. Okay, I guess it doesn't work. So, okay, that's great. It's good to know it works. What is next? Next, we have Alice earns $400 every 15 days. Bob earns 3.14 per hour and works 8 hours a day, 7 days a week. After 30 days, has Alice earned more than Bob? Okay, sure. So let's copy it. We'll get it here. And let's just make some room. So our task is, what was it? Something like this? Yes. And we can just paste it here and divide it so that we can have it displayed nicely. So we have that statement, we have next statement after 30 days, and of course our hint. Cool. We just indent it a little bit to look pretty. Awesome. So, okay. So we care about 30 days. So in this case, 30. This is divisible by 15. So I guess we just do that. So let's do just something like let Alice per day. Okay, will be $400 divided by 15 days. Okay, that's simple. Now I will keep things as floats. Then let Bob per day. Okay. We know that he works 7 days a week, so we don't need to subtract that and skip any days. They kept it simple. So Bob per day is basically 8 hours a day times 3.14. And right now this will be happy. I'll just do that just so it's happier. We don't have to, okay? It makes it float anyway. Cool. So we basically do, we can do 30 days, but it doesn't matter because all it comes down to is earned per hour. So we can just do, sure, let Alice after 30 days do Alice per day times 30. Let Bob after 30 days equals Bob per day times 30. You know, we did both of them times 30, so it doesn't matter on mathematical way, but whatever. So echo, and let's do Alice earned more than Bob. And we'll say Alice after 30 days is more than Bob after 30 days. And let's see what we get. Yeah, let's also do the other. Earn less. And we just did that. They want us to just has Alice earned more than Bob. Okay, so we just need that one. Let's earn more than Bob. We'll say true or false. Let's run it. And we have Alice earned more than Bob. True. Cool. So she got 800. Bob got... Okay, I'm not good at math. Echo. Alice is... Alice after 30 days. Then we have Bob. And we do Bob for 30 days. Dollars and dollars. Save it, run it. There we go. Bob is $50 less. Alrighty. So getting back to our exercises, we finished our first set. All right. So this apparently was the longest chapter. So yeah, that was a long time. It took me, how long am I streaming? Hour and 20 minutes. Wow. All right. Cool. So let's move on. Let's not prolong it. I want to know more about Nim. So control flow. Now we get into the fun stuff. So far in our programs, every line of code was executed at some point. Control flow statements allow us to have parts of code which will be executed only if some Boolean condition is satisfied. If we think of our program as a road, we can think of control flow as various branches, and we can pick our path depending on some condition. For example, we will buy eggs only if their price is less than some value. Or if it is raining, we will bring an umbrella. Else, we will bring sunglasses. So written pseudocode, these two examples will look like this. If egg price is less than wanted price, buy eggs. If it's raining, bring umbrella. Else, bring sunglasses. Nim syntax is very similar, as you'll see below. If statement. An if statement, as shown above, is the simplest way to branch our program. The Nim syntax for writing the statement is: if we give it some condition, we have that little colon, and then indented block what happens if the condition is met. Okay, the condition must be of type Boolean, either a Boolean variable or a relational and or logical expression. We're gonna test it in a second. All lines following the if line, which are indented two spaces, make the same block and will be executed only if the condition is true. Okay. So if statement can be nested, one if block nested. An example, inside one if block there can be another if statement, etc. Okay, makes sense. So let's try something. Let's get rid of this exercise and we'll do if, I don't know, 1 is less than 2. Echo math works. Okay. So if we'll save it and run it, you get math works. Awesome. So what's next? So what I wanted to say, because they said that it needs to be true or false. In C languages and many other languages, I could also define something, you know, let's say we have a variable is true. And we'll say true, right? If we'll replace that, save it, we run it, math works. Awesome. So what if I'm gonna turn it into 1? That's integer. Okay, it doesn't like it. We actually need to say is 1 or is larger than 0. So it's good to know that in nim, this actually needs to be either true or false. It doesn't try to pretend that 0 is false and everything else is true, or that string is true while empty string is not true. That's hint for JavaScript, for example. Okay, good. I'm happy to see that. It's explicit. And we can nest things, right? We have let A be C, and if A is less than B, we can echo it. And if 10 times A is less than B, not only that, it's much more. So we can nest our if statements, one inside the other, because we have 2 indentation all over here, while this one has extra 2. Okay, the same thing goes here, and the same thing goes here. But this is an example where we're also, you know, having multiple instructions. They have the same indentation, therefore they all belong to that specific if statement. And we can do something complex where we use our AND operand. No, and what was it? Operator. Cool. Yeah, it just shows that, you know, it will skip some things because it's false, so it won't show it. But I guess we can assume that this is, you know, basic programming, so you don't have to worry. Okay. Else follows after an if block and allows us to have a branch of code which will be executed when the condition and the if statement is not true. Okay, that's classic too. So if this is true, this will be executed, but if this is not true, this one will be instead. Same thing goes here. So this way we can handle both cases. Okay. And then we have elif. Instead of else if, we have elif. And yep, short for else if. It enables us to chain multiple if statements together. The program tests every statement until it finds one which is true. After that, all further statements are ignored. Okay. So we can basically check if it's this, if not, maybe if this, if not, maybe if this. And if none of those, it'll print that. Cool. Very basic. So let's move to more interesting things. A case statement is another way to only choose one of multiple possible paths. Similar to the if statement with multiple elifs, a case statement, however, doesn't take multiple Boolean conditions, but rather any value with distinct states and a path for each possible value. I guess each possible value is a hint here. So, code written with an if elif block looks like this. If it's 5, 5. Else, if it's 7 or 10 or whatever else, it's can be written with case. So this is like a switch statement in many other programming languages. We do case and the x, so we're checking what the x is. So we have a case of, that's fun to read, case of 5, do this. Case of 7, do this. Case of 10, do this. And if none were matching x, we print the else. So, you know, theoretically, you have what? 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Here we have 9 lines of code because you need to add that one. So you might think, it's more lines of code. Why would I use that? But at the same time, look, you don't have to repeat those crazy characters non-stop every damn time. You can just have simple, readable, okay, I'm checking for X, all those numbers, and default case. Awesome. Unlike the if statement, case statement must cover all possible cases. If one is not interested in some of those cases, else discard can be used. Okay, so this is something that many people like, and it's slowly coming to different languages that have pattern matching and etc. Basically what it means that if we wouldn't have this else here, the compiler will be unhappy, right? Let's try it. So if we'll place it here, and right now we don't have X, so let's say let X equal 8, okay? If we'll save it and run it, we'll get that get an unknown number because there was no case for it. If we put it to 7, we'll get 7 printed as expected. 7, there we go. So that's good. But if we'll remove this else case, suddenly, hey, not all cases are covered. So what this does, it basically protects us from the situations where we skip the number. Or I presume we could have enumerations or some other possibilities in the future. And therefore, if let's say we have a set of 5 possible values that can be assigned to X, and we cover them all, we'll be happy. But if at some point in the future we added one more possible value, and we forgot that somewhere in our code base we have case over that, compiler will notice that, and hey, you had that one spot where you missed to check for that. And this way we will, we won't have that weird bug that happens from time to time. It will be just covered from scratch. So I'm very happy to see that. That's a feature that a lot of developers are looking for nowadays. So me too. So I'm very happy about that. And in case you know that you don't want to do anything with here, instead of, how do I make it empty? Because I presume if I will do that, save, yep, we have invalid indentation. If we have no indentation, what's going to happen? Invalid indentation, it expects something here, but there's nothing. So that's why we have this discard. We can just do, hey, discard it. This way we explicitly said that, hey, there's nothing happening here. No reason to complain. We handled it that way because we need it that way. So that's good too. Hey, if we can do else discard here, can we just do that? Oh, we can. There we go. That's much shorter. Cool. Okay. So we can also use multiple values for each branch. Wait, we missed one thing here. Look, we're switching over a character Y. So we can switch over characters to see what character it is. And if non-selected, we'll just discard it. That's very nice to see. Okay. So we can also use multiple values for each branch if the same action should happen for more than one value. So we have our I equals 7, and we case, but how do you read it? Case over I. So we have case of 0, we do something. Case of 1 or 2, or 3 or 5 or 7 or 9 is odd. Those cases are even, and else we have too large. That's awesome. We can just enumerate those. I'll be happy. We don't need to do something that some other language with a switch statement. It wouldn't allow you to write something like that. You will need to do of 1 and then have of 3, and you just keep going with 5 and 7 and 9, right? That's what you would need to write. And then you have that, and you need to remember to, hey, I need to break the thing. So suddenly your whole thing is overly complicated. Here is nice and clear, right? Really easy to read. You can, if it's short, you can even do that if you want. And bam, you have something that's concise, really easy to grasp. I really like it. Okay, I'm excited about switch statement. Okay, so I guess that's it for our flow control for now. Not bad, that was a short chapter. I don't know, loops are also flow control. So loops are another control flow construct which allow us to run some parts of code multiple times. In this chapter, we will meet two kinds of loops. For loop, run a known number of times, or a while loop, run as long as some condition is satisfied. Okay, that's simple enough. For loop. Syntax for a for loop is for something and something. So a loop variable and iterable. Okay, a loop body. So we can say that we iterate over a list of something. And here we're gonna get each item. And here we can operate on those items by using that variable. Awesome. Traditionally, I is often used as a loop variable name, but any other name can be used. That variable will be available only inside the loop. Once the loop has finished, the value of the variable is discarded. The iterable is any object we can iterate through, of the types already mentioned. Strings are iterable objects. More iterable types will be introduced in the next chapter. So, all lines in a loop body are executed at every loop, which allows us to efficiently write repeating parts of code. If we want to iterate through a range of integer numbers in nim, the syntax for the iterable is start ... finish, where start and finish are numbers. So iterate through all the numbers between start and finish, including both start and finish. For the default range iterable, start needs to be smaller than finish. Okay. If we want to iterate until a number, not including it, we can use the ... and less than. Okay, I like it. So we can say for iterate from numbers from 5 to 9, including 5 and 9. We can echo each number in it. Awesome. And then we can, I guess this will be to just answer the empty line. And then we can have the same iteration, but in this case, because this extra symbol is here, we iterate from through numbers 5, 6, 7, 8, but not 9, because less than 9. Okay, this is what usually programming languages we're doing, but I definitely prefer those inclusive ones. That's awesome. All right. There we go. This goes to 9, while this goes only to 8. Simple enough. If we want to iterate through a range of numbers with a step size different than 1, COUNTUP is used. With COUNTUP, we define the starting value, the stopping value included in the range, and the step size. Oh, awesome. So we can iterate over from 0 to 16, where we increase over 4. So it will be 0, 4, 8, 12, 16, because 16 is included, and that's it. And we just print those numbers. So there you go. That's simple. I like that it's built into the language. It feels like it's then, whenever you need something like that, it's like, oh, I need to write that function, or in JavaScript world will be, oh, I need to find a library that does that for me. Built in the language, easy to remember, awesome. I wonder if there's also countdown or something. To iterate through a range of numbers where the start is larger than finish, a similar function called countdown is used. There we go. Even if we're counting down, the step size must be positive. Okay, so when we count down from 4 to 0, Oh, if we skip the number, we'll iterate over over all of them. Well, here iterate 2 down, so we don't use -2, which is 2, and this knows to go down. All right. Yep, makes sense. So string is an iterable. We can use a for loop to iterate through each character of the string. Awesome. This kind of iteration is sometimes called for each loop. Yeah, okay. So we have a word, alphabet, and for each letter in word, I guess it's for each so that you can read it nicely. So for letter in word, so we get the word and we'll do something over each character, and that something will be to print it. So we print 1 character per line. Awesome. If we also need to have an iteration counter starting from 0, we can achieve that by using, again, for, then we define a counter variable and loop variable with the comma in the middle, and an iterator. Okay, this is very practical if you want to iterate through one iterable and simultaneously access another iterable at the same time, at the same offset. Okay, so we have for I letter in words. So we again iterate over that word. For every character, we do something for every letter. So we define that letter, but before that we define this I, so this will be an index of it. So it will be 0, 1, 2, 3, 4. And we print letter, that index number is, and that. So we go letter 0 is A, letter 1, 2, 3, 4, 5, 7, and we have that for that. So this way, let's say we have that word and we have another word, we can probably just print out, use that index to get characters of the other word or some other list, or, you know, this allows us to iterate over many things at the same time. Okay, I really like that it's available for any kind of iterator, because there were too many times where I needed to write like a little for, I need to keep track of some extra variable in there to remember, oh, I need to increase it, and, you know, it's another point where you could introduce, you know, bugs or into your program. You know, most of the time you will notice that there's something wrong, and oh, of course I forgot about that. But again, it's another 1, 2, 5, sometimes an hour lost, because, you know, there are some programs that you write are, you run it instantly and you see that something's wrong, but sometimes, you know, you have elaborate setup and it takes you, you know, an hour between you executing the code, seeing that there's a problem, finding the problem, rebuilding the whole program, you know, posting it somewhere and re-executing, and, you know, you just lost an hour because, oh, I forgot to increase an I at the end of the loop. And, you know, saves you time, it's easy to read, love it. Okay, let's go to the while loop. While loops are similar to if statements, but they keep executing their block of code as long as the condition remains true. They are used when we don't know in advance how many times the loop will run. We must make sure the loop will terminate at some point and not become an infinite loop. That's true. This is, you know, the for loop. We already tell it that, hey, go through everything in a word, so, or go through the range of between here and there. So it will run at a specific time, and it, you know, the compiler takes care for us to stop the loop at some point because, oh, we reached the end. With the while loop, we need to be careful because we set the condition. We have to specify when the change happens that, oh, the loop is gone. You know, we should stop it. So we declare a variable a equals 1, and we do while a times a is less than 10, then we execute that code. So if you imagine that you know, here we have 1 times 1 is 1, so 1 is less than 10. So if that code inside the loop won't be changing a, it will basically run forever, and you know, it will never stop. It will look like your computer hung, or in this case, it will just keep printing that A is 1, A is 1, A is 1. That's why here we need to remember deadline. Increase A. And increase is used to increment, or increment A. It's used to increment A by 1. This is the same as writing A equals A plus 1, or A plus equals 1. Okay, so we have also plus equals assignment. Cool. So we have simple, very easy to read, increase 1. Okay, I guess they're not mentioning A++, so that isn't available, maybe? I guess we'll learn. And this way, as A increases, it'll be 1 times 1 is 1. That's less than 10. Okay, it's 1. Increase A, so A suddenly becomes 2. 2 times 2 is 4, still less than 10. Print 2. Increase, we have 3. 3 times 3 is 9, still less than that. Then we have 4. 4 times 4 is 16. And that's larger than 10, and that's like, oh, okay. It's time to stop the loop, and the program, instead of executing what's inside, will just skip after it, which in this case is the line echo. Final value of A is, in this case, will be 4. So if I'll take that code and run it, there we go. 1, 2, 3, and final value is 4. Perfect. Okay. So, break and continue. The break statement is used to prematurely exit from a loop, usually if some condition is met. In the next example, if there were no if statements with break in it, the loop would continue to run and print until I becomes 1000. With the break statement, when I becomes 3, we immediately exit the loop before printing the value of I. Let's see. We define a variable I. It can change because we have var here. So I is 1, while I is less than 1000. So, okay, it's just 1. And then we check inside. This is the inside of our loop. So if I is 3, then we break. But it's not, it's 1. So we print 1 and increment I. So 2 is less. Nope. Print 2. Increment 3. So while I is less than 1000, correct. If I is 3, we break it, and break basically finds the first loop and like, oh, okay, you're done. It immediately goes after the loop. It doesn't even bother checking it anymore. It just jumps after the loop. Cool. The continue statement starts the next iteration of a loop immediately, without executing the remaining lines of the current iteration. Notice that how 3 and 6 are missing from the output of the following code. So if we go for a range between 1 and 8, and we want to print every single one of them, but if I is 3 or 6, we continue. So we basically, the moment we see this, we instantly jump to next iteration. Bam. In this case, it will increase the go to the next thing and run again. This you could also use continue with while loop. If we would do if I equals 3 and do continue, we would just skip printing and incrementing the 3, and we would just go straight up here, and I would be still 3, so we go back here and continue, go up and up and up and up, and we will just be stuck here forever. Not even printing anything. So, in other words, continue starts iteration from scratch. So basically, after when computer sees continue, it goes back to the beginning of the loop, including checking for the condition, or in case of for loops, going over to the next item. While break just moves it out of the loop, just skip the whole thing and finish the loop. Okay. We've got exercises. Collad's conjecture is a popular mathematical problem with simple rules. First, pick a number. If it is odd, multiply it by 3. and add 1. If it is even divided by 2, repeat this procedure until you arrive at 1. Okay, so let's just copy it and do that. So pick an integer as a mutable value and create a loop which will print every step of the callout conjecture. Okay, that should be simple enough. Joe Pan says hello. And oh, thank you for reporting. I'm new to streaming, so I didn't know how to report yet. I guess I'll need to learn it to keep things sane. Okay, so let's solve this problem. It should be relatively simple. So let's divide it by little statements. And our codes should resemble that. So first pick a number. In our case, they are asking us for mutable variable. Okay, so we'll be basically modifying it. Okay, so we do variable. Let's call it number. And let's pick a number for now. 80. Why not? It's a number. So, if it's odd, multiply by 3 and add 1. If it is even, divide by 2 and repeat this procedure until we arrive at 1. So we do something until something happens, so we want our while loop. And until we arrive at 1. So while the number isn't 1, we'll be doing whatever needs to happen in our loop. So in this case, in this loop, we first check if it's odd. Okay, so let's do if number mod 2. So if we check if it's divisible by 2, that will tell us if it's odd or not. So if it's odd, that means it won't be divisible by 2. It will return 1, the modulus. So if that's the case, we want to basically specify that multiply it by 3 and add 1. Okay, so we do that number is by 3. So number times 3 plus 1. And because this is a multiplying, it executes first. But for practice, for nice practice, I like to explicitly wrap it in parentheses to say that, hey, make sure you run this first and then add 1. You know, it won't make a difference for the compiler, but you as a reader of somebody else's code, you don't have to think like, especially in more complicated things like, oh, I need to multiply first. I need to, which goes first? Or am I working with, you know, in the future you might have a job where you deal with 3 different programming languages and suddenly you have to think like, wait, I'm in this repository, means I'm using this language. Did this language respect those different operator orders or not? And in parentheses, you don't have to think. You just work faster. So if this happens, we just do that and continue. We just move to another iteration. We check if it's 1. But if that didn't happen, we can do if else. Elif, and we check if it's even, we divide it by 2. So we just do else then, because we checked if it's uneven, if it's odd. So the other option is it's even. So we just do else, and if it's else, divided by 2. So number equals number, and we div 2. We're dealing only with integers, so I presume that we won't do only integer division here. They give us a hint, right? Use div for division. Okay. Yeah, Let's just do that. So we use it for division, and we do continue. So as far as we know, we just repeat it until we arrive at 1. And the only thing is that they ask us to print every step of the Collatz conjecture. So we'll print every step. So let's look at it. We have only those 2 cases. It's either odd or not. We can even say, we can specify a variable here. Let is odd, and this will be, wait a moment, it'll be this. Okay. So, if it's odd, do this. If it's not, do that. A little bit easier to read. But because we know that we have only those 2 cases, we can actually, and we would need to do, hey, echo, and we do the, we need to echo the number, but they did it in a nice way where they just added arrows in between. So we can literally grab it, and we can just say, hey, put this here, and print this out. We just need to make sure that we start with a number, so we do echo number, and then we'll be adding that. So we can echo this, and then we can, top of me missing the B, we can do the other one. So that will work, but I personally see a problem here. We're having to write this twice. What's the point? Then we have continue twice. We can let it basically do this, where if it's odd, it will do that, and only if it wasn't odd, it will go here. So that means the code that was after it will be executed always after one of those. So we can just echo here and remove the continue, because that's the end of the loop, so we'll start going. And at the end, after the loop, we'll remove the indentation here, and we can do echo, and we'll do finished. So let's try to run it, see if it works. So for 80, we go to 40, 20, 10, 5, 16, 8, 4, 2, 1, finished. There we go, problem solved. Not like this? What did I do? What did I do wrong? Okay, in the meantime, I'll continue to the next. Create an immutable variable containing your full name. Write a for loop which will iterate through that string and print only the vowels. Use case statement with multiple values per branch. Okay. That's simple. Okay. Sure, that'll be simple. Just check on that. It's all good here. On YouTube, Seth Rollins says hi. Hello to you too. Okay. So, let's go back to our code. This one will be much simpler. We need to, wait, let's use those fancy things. Look at that, I'm already using wrong comments. It's all habits. Okay, so create immutable variable containing your full name. So let name is Benedict. There we go. Then write a for loop which will iterate through that string and print only the vowels. So we do for loop. So for letter in name. So that's all we need to do to iterate over all the characters. Compiler where the hint says letter is a character. And write and we'll print only the vowels. So we can do the case of letters. All right. And we'll have case of A. And let's say we have the case of A, then we just do echo letter, right? And if that's not the case, else we discard. We don't want to do anything when we don't have anything else to, we are supposed to print only the vowels. So I could do this and then off E and also echo letter. I could go on like that, no problem. But they give us a hint. Use case statement with multiple vowels per branch. So in this case, we have only 2 branches. One where we're writing something and one when we're not writing something. So that's it. So A, E, I, O, or U. That's it. Why doesn't like it? Oh, because we need this. And that should be it. It should print out E, U, E. So let's get rid of our previous code because it just clogs everything. And save it and run it. E, U, E. That's it. I guess in theory I should worry about there being capital letters or not. So I could add A and E, I. Wait a moment. I. O. Oh my. I constantly want to type strings and stuff, characters. And we have the last one, U. Okay. This will suddenly handle other things. Let's say something like and Smith, or let's go something O. I don't have any surnames coming to my mind right now. Uber's surname. There we go. And when we run that, now we include our vowels that are capital letters too. And hey, not pretty, but if we wanted to use if statement instead of case statement here, we would need to write something like if letter is A, right? Or letter is E, or and you see how it suddenly begins to be really lengthy. So it's really nice. I really like that. It saves a lot of time and confusion. I like it. Okay, next. FizzBuzz is a kids game sometimes used to test basic programming knowledge. We count numbers from 1 upwards. If a number is divisible by 3, replace it with fizz. If it's divisible by 5, replace it with buzz. And if number is divisible by 15, both 3 and 5, replace it with FizzBuzz. First few rounds would look like this. Create a program which will print first 30 rounds of FizzBuzz. Yep, beware of the order of this divisibility tests. Exactly. So I actually must say that I never wrote FizzBuzz myself. I read that it's so many times it's like a simple interview question for some reason. It seems a bit simple for an interview question. But sure. Let's do that. So we get rid of that. We get our thing here. What we need to do with fizz, with buzz, and if it's both, do that. And first few rounds would look like this. We don't care. And we need to print 30 rounds of FizzBuzz. And we have the hint, beware of the order. So we know that we need to do a specific 30 rounds. So that tells me instantly we have a specific number. We do 4. So let's do I for that number off, and we can use the, we start with 1, right? From 1 upwards. So 1 to 30. We include that 30. Okay. And it's an error type. What the hell? Do we need spaces here? I don't know, we'll see. For now, I assume it's correct. So, if the number is divisible by 3, replace it with fizz. If something else, do something else. And if something else, do something else. So again, I feel like this would be a good example of a case statement. So, case I. And we have case of it's being divisible by 3. So we take the I mod 3 equals 0. It's divisible by 3, right? If that's the case, we print echo what we do fizz. Then doesn't like something. Ah, look at that. Cannot evaluate a compile time. So we found the first limitation. That the case statement works only with compiled things. So that means we need to switch it to if. So if I mod 3 is 0, we echo fizz. Else if we have the 5, right? If this will be 5, replace it with buzz. So I mod 5 equals 0. Echo buzz. And then if I is mod 15, we will echo fizz buzz. And then we had the case when there is nothing else. Count number. Okay. So if it's the thing, then we just echo the number, which will be here. So I'll run it right now, but it will already be wrong. What is wrong here? Or in. There we go. So let's run it, but I already know that this will be wrong. And we've got 1, 2 fizz, 4 buzz fizz, and then we got to 15. It's just fizz. So that's where was the hint. What the hint was. Beware of the order of the divisibility test, because the if statements will go from the top and try one by one. So we want to check for 15, but if we check for 15, 3 will go through, because whatever's 15, divisible by 15, will be divisible by 3 and 5. That means we actually need to do the this statement first. Okay. So we do the fizz buzz, and then elif, and I would say the 5. I just want to check then, like, this is the larger number that's being checked for division. I don't have an example in my head right now because everything else would be by 15. So I guess those two don't matter. But that's the case here. We just need to move them around, order them properly, and now we should get a proper order of things. I assume. Let's check first 7. So, where'd it go? Okay, fizz buzz. 1, 2, fizz, 4, buzz, fizz, 7. 1, 2, fizz, 4, buzz, fizz, 7. There we go. And for number 15, we got the fizz buzz. So we're good. That was simple. I guess it's for testing like really basic knowledge. Oh wow, that page doesn't like scrolling. And we've got the last exercise, and after that we have new chapter, and we're already talking for 2 hours and 10 minutes, so I'll just do this one and we'll be finished. So, in the previous exercises, you have converted inches to centimeters, and vice versa. Create a conversion table with multiple values. For example, the table might look like this. Okay, sure. Let's grab it as an example and let's code it. Let's do it like that. I'm going to actually decrease the size of the font a little bit here because we'll have a little bit more code. And let's add our example here. Okay, this will be our table. Their table looked nicer. I guess I need to paste it like this. Nope. Doesn't work. There we go. For now, I'll ignore and I won't worry about spacing. That will be a lot of if statements. I just don't feel like doing it right now. It's something relatively simple to do. It's just... we'll see how we go. So, I presume we'll have a list of values to convert. Let's say that our values... okay, we'll do that later. Let's do it like that. We'll iterate over the values in inches and print them out in centimeters. So let's do a for loop, and this will be inches. And we say from 1 to 30. Okay. And now we're iterating over those inches. So we need to calculate how many centimeters that is. So we do let cm for centimeters will be inches divided by 2.54. So that suddenly will be unhappy because we have a float and we have that. So let's just do it as I, and we'll just make a variable let inches, and this will be float of I. So we have our inches as a float. We declare centimeters also as a float. And now we can print the table. So for the first thing, we need to print those 2 lines. So we can just do echo and give it that line. Then we can go and print this line. So echo, bam. And from there, we'll be just assembling those. So the simplistic way here would be to just do echo, and we do, we can do inches, then we'll print 1.0, 4.0, 7.0. So maybe for that, we'll actually use the I. So we print I, after which we just print a space, pipe, space. And after that, we're gonna print the cm for centimeters. I presume this will show some long names. I mean, a lot of characters. I don't feel like going through documentation to find how to format it nicely. That's for later. we're just learning loops for now. So if I will run this thing, what is going to happen? We've got our table. Inches, centimeters, and we have that. So let's say that we actually want to make it like nicely aligned, like they did it here. So the simplest way here, in the way that we know right now, is to say, hey, if this is less than 10, add 3 spaces. If it's less than 100, add 2 spaces. And in other cases, add something else. So we can, I guess, calculate that relatively easily. So let's say that those spaces here, we'll just do spaces, and then we add the pipe. So let's do var spaces. And this will be our triple space. And then we do case I. Oh no, because here we're checking for larger, lesser. So if I is larger than, so right, let's just do 1. 1 will be for like the thousands. If I is less than 10, spaces is 3. And else if I is less than 100, spaces is just 2 spaces. And for everything else, the spaces will be just a single space that we declared before. And this way, that value should be inserted here, and hopefully we're gonna get a nicely formatted table. There it is. Perfect. And we have from inches to centimeters. Not really. I should multiply rather than divide. There we go. Multiply. And run it again. And oh, we suddenly got nicer values. Other than this weird one here. And this is what the floating point numbers do. Sometimes, even though you do 26 times 2.54, which should be exactly 66.04, there was some little, mishap that the closest value to 66.04 that was possible to represent was this. With that extra little wiggle room there, like a little bit more. So, yeah, that's the thing. But hey, that worked. Looks great. So this way we finish the chapter of, what was it named? Control flow and loops. And we have just a few more things done. We are way more than past the half of the tutorial. So I guess in next stream, during the next stream, we'll go over different containers like arrays, sequences, indexing and slicing, tuples, and exercises. That chapter, I presume, will go a little bit slower because we'll need to look at some, the code will start beginning to be a little bit more complex and where it differs from different languages. Then we'll go through procedures, which I presume are functions or methods, declaring them, calling the procedures, result variable, forward declaration, exercises. Again, this might go a little bit slower because, again, the code is getting more complex. Then we'll go over modules, importing module and creating your own. I don't think there will be a lot there. And then interacting with user input, reading from a file, reading the user input, dealing with numbers. Here we're finally starting to write something that is interactive. It isn't just run and done. So this is where the fun will begin, and then we have conclusion. So just those 4 chapters. I think we'll fill next 2 hours, probably on Friday with that. So that will be it. Yeah. I want to